Hi, welcome back. So in this video, we are going to discuss June 2022 Mechanics M1 question number 5. So here, a uniform road AB has length 5 meter and mass 5 kg. So this is a uniform road. Uniform road means the weight will be acting exactly at the center. So this is a 5-meter road. So the weight will be acting exactly at the center. That is 2.5 meter from A. So from A 2.5 meter, we will be having the weight acting downwards. So mass is given as 5 kg. So if mass is 5 kg, then we know weight is mass into gravity. That is 5 into g. So the weight acting will be 5g. And the distance here is 2.5 meter. The road rests in equilibrium in a horizontal position on two supports C and D. In this chapter, whenever we have a support, there will be a normal reaction acting upwards. So here at the support C, we have RC, and at the support D, we will be having RD. AC is given as 1 meter, so AC is 1 meter, DB is 2 meter, DB is 2 meter, so altogether it was 5 meter. So C to D, it will be 2 meter, another 2 meter. A particle of mass 10 kg is placed on the road at A. So at A, we have a particle of mass 10 kg. So the weight acting will be 10g. And a particle of mass m kg is placed on the road at B. So at B, we have a particle of mass m. So weight will be mg. Find in terms of m the magnitude of the reaction on the road at C. So the reaction at C is what they're asking. So that means we need to find out what RC is. We need to find what RC is. In order to find out what RC is, we are going to apply the concept of moment here. We'll be considering the moment at D. The reason why we are considering the moment at D is that to find RC, we need to remove this unknown RD. So to remove the unknown RD, we are going to take the moment at D. When we take the moment at D, all the forces acting at that particular point can be ignored. So here, considering the moment at D, so the force acting at D, RD, can be ignored. And according to the law of moments, we know that clockwise moment is equals to anti-clockwise moment. So you can write clockwise moment is equals to anti-clockwise moment. So let's see the direction of all the forces acting here. 10g is going anti-clockwise direction. So the moment at D is what we are considering. So 10g is going anti-clockwise. So moment is force multiplied by the distance. So force is 10g multiplied by the distance from A to D. It is 1 plus 2, that is 3. Now, the next one, let's say RC. RC is the next force which is going in clockwise direction. So this is a clockwise moment. RC, from RC, the distance from the moment D here, the distance is given as 2 meter. So RC into T, RC into 2. And then the next force acting here is 5G. And 5G comparing with the point D, we know this is going anti-clockwise moment. So 5G, it was 2.5, and then from A to D it is 3. So the distance between 5G and D is 0.5. So the anti-clockwise moments 5G into 5G into 0.5 is the distance. Now the last one is mg. Mg is clockwise moment. So from mg till the point D, the distance is given as 2 meter. So it's a clockwise moment. So plus mg into 2. Since we are finding out RC, bring all the terms to the other side. So RC into 2 is 2RC is equal to 10G into 3, that is 30G, plus 5 into 0.5, that is 2.5G, minus 2 mg. 2 mg will be the, now 30 into 9.8, 30 or 30 plus 2.5 g, we'll get it as 32.5 g minus 2 mg. 32.5 g, so 32.5 into g value, we can take it as 9.8. So 32.5 into 9.8 will give you 318.5. 318.5 minus 2 into g, that is 2 into 9.8 will give you 19.6. 19.6 m. Now 2 RC is what we got here. 2 RC. So RC is what we need to find out. 318.5 minus 19.6 m, the whole thing divided by 2. So 318.5 divided by 2 will give you 159.25 minus 19.6 divided by 2. 19.6 divided by 2 will give you 9.8 minus 9.8 m. This will be the first part. We got the value for RC. So the question was to find in terms of m the magnitude of reaction on the road at C. So we got RC in terms of m. Now moving on the second one here, the B part, find in terms of m the magnitude of reaction on the road at D. So that means here reaction at D is what we need to find out. Reaction at D is what we need to find out in terms of m. So we have a point here. The road remains horizontal and in equilibrium. If the road is in equilibrium, the forces acting up is equal to the forces acting down. So we'll just draw the forces here. We know that at A we were having 10g, and then at the middle 2.5 we were having 5g, and then we were having mg here, and we were having rc and rd. So basically, if the forces are, or if the road is in equilibrium, we can say that the forces acting up, rc plus rd, is equals to forces acting down, that is 10g plus 5g plus mg. Now we already got the value for rc. rc is 59.25 minus 9.8 m. So RC, I'll replace it with 159.25 minus 9.8 m plus RD is equals to 15g. 10g plus 5g is 15g plus mg. Now minus 9.8 m goes to the other side. We just basically need RD on the right hand side. So 15g, 15 into 9.8, 15 into 9.8 is 147. 147 plus mg. G is 9.8, so that becomes 9.8 m minus 9.8 m goes to the other side, it becomes positive 9.8 m, and 159.25 goes to the other side, it becomes minus 159.25. So 9.8 m plus 9.8 m will give you 19.6 m, and 147 minus 159.25 will give you minus 12.25. Minus 12.25. This will be the value for RD. Now we have the last part here. Hence or otherwise, find the range of possible values of M. So once again, let's just simply draw the forces here. At A, there was 10G acting. 2.5 meter, we were having 5g, and then we have mg here, and then we have rc acting up and rd towards acting up. Yeah. Now find the possible values of m. Find the possible values of m means if the m value is very big, if the m value is very big such that, you know, it will be tilting at the point, or the uniform road will be tilting at the point D. So if it is tilting at the point D, we know that according to the law of tilting, RC is supposed to be equal. So what we are finding out is the maximum value of m. If the m value is so big, so it starts tilting at D. It starts tilting at D. If it starts tilting at D, then the reaction at C, there won't be any contact at C since it's tilting at D. So RC we can equate it to 0. You know, previously we found the value for RC. It was 159.25 minus 9.8 m is equals to 0. So minus 9.8 m goes to the other side. It becomes positive 9.8 m is equals to 159.25. So m will be 159.25 divided by 9.8. So when you put that in calculator, 159.25 divided by 9.8, you will get the answer as 16.25. 16.25 will be the maximum value of m. Now we have one more condition. So the next condition is when the m value is so small such that the uniform rod is going to be tilting at C. So at C, it will be tilting. If it is tilting at C, what happens? There is no support at D. We can say that RD is equals to 0 for minimum value of M. So once again, the first portion was the M value is so big so that it starts tilting at point D. The support at C is no more there. So RC you equate it to 0 to get the maximum value of M. Now, M value is so small, therefore, the 10G compared to 10G, M value is so small, therefore, the support starts tilting at C and there is no more RD value. There is no support at RD. So we already found the value for RD as 19.6 M minus 12.25. So in the second case, RD, you can equate it to 0. 19.6 m minus 12.25 is equals to 0. So 19.6 m is equals to 12.25. So m will be 12.25 divided by 19.6. So 12.25 divided by 19.6 will give you 0.625. 0.625. So this is the minimum value of m. Minimum value of m. So we can say that m should be greater than 0.625 and m should be less than 16.25. This is the range of possible values of m. So I hope you understood this. If you have any doubt, please let me know through the chat box. Thank you for watching.